All right, this is the second set of practice problems from the H10-7 notes. These ones will go along with some of your homework problems. That's why I included this in the notes here for you to practice if you need to. So, the direction state practice says evaluate the geometric series described, then find the sum of the series. So we'll look at letter A first. For A, it says we're going to find the sum from the first term to the 8th term of the series that's defined by that argument right there. So what I'm going to do here with this here, I'm actually going to write out the series right now, just to make sure that we're following along with everything that's going on with this. These ones can get confusing when you're asked to do them on your own. So we're going to find the sum from the first term to the 8th term. So we know there's going to be 8 terms here. And remember, we find each of those terms. Let's see here. I'm going to put out 8 little blanks here. Okay, so we've got here, right? If I plug in 1 into here, into the argument for n, right, it gives me my first term. In this case here, the first term we're going to be looking for in this series here will be 4, right? If I plug in 2, 2 minus 1 is 1. 2 to the first is 2 times 4 is 8. And then notice my multiplier is 2, so it looks like everything's going to continue to double over and over again, right? So if I plugged in 3 into that one there, I should end up with 16. And then that would be what, 32, 64, 128, 256, and 512. Those are the 8 terms that are in this series. Do we have to know all of them here to find the sum? No, we do not. Okay, but we definitely need to make sure we know what this first term in that we're going to be dealing with is. Okay, so we definitely need to make sure that we've plugged this number in for n to get that first number. All right, so as we go through and do this, we can just go ahead and use our formula then if we want to. We can say here the sum of the first 8 terms is going to equal our first term, 4, times our multiplier, which is 2, raised to the power of n, which is 8, minus our first term, and then we're going to divide it all by r minus 1, so it would be 2 minus 1. And in this case here, when we take it there, I've already calculated the answer, you should end up with 1020. Now, if you were asked to do a problem like this there and you could not remember the formula, but you were able to create this series, then you could take it and you could just add them all together, right? If you're just asked to find the answer and everything here, then, do what you have to do to get the answer. Okay, the second one, let's look at it. So letter B, we're finding the sum from the first term to the 4th term of the series that's defined by that argument there, right? So we know that there's going to be, from first term to 4th term, we've got 4 terms. We've got 1, 2, 3, 4. There's 4 terms. First term, second term, third term, 4th term. And there's a reason I'm emphasizing this because when we get to see it may seem a little different. So if I take it there and I plug 1 into that expression to get this term right here, we would end up with 128 is the first term in the series that we're looking for. Now if we plug in 2, 2 minus 1 is 1. 128 times 0.5 is going to be 64. So it looks like we're just going to multiply everything times a half. There's 32. And then this last one would be 16 there. Now we could take and we could add them all together to get the sum, right? It's only 4 terms, so you could do that. But let's just practice using the formula. We have sum of the first 4 terms is going to be 128 times r, which is 1/2, raised to the power of 4 minus 128. And then we're going to divide it by r minus 1. So 1/2 minus 1. So before I take that and try to type it in the calculator here, right, I would say here, I could simplify just a little bit more and say 128 times, well, you know what, I'll just leave this first part the same. But on the bottom, 1/2 minus 1 should be a negative 1/2. So you could take it and type that into the calculator here, and when you do it, your answer should end up being 240. Okay, so if you think about this real quick here, right? Remember, this right here is what we consider to be the next term. If I did 128 times 1/2 4 times, here's what I get when I multiply it times 1/2 once, times 1/2 twice, times 1/2 3 times. So this is really the same thing as 8, right? We'd have 8 minus 128 would be a negative 120, divided by a negative 1/2 would give us a positive 240. Same thing right here, right? This number here, it's just the next term. So if you think about it, 4 times 2 to the 8th power, what is that going to be? Well, it'd be like this number here that you got afterward. If you just doubled 512, you would have 1024, and that's the number you get when you type it in there. If you wanted to just write in 1024, if you figure that out on your own, you could just do that instead. Okay, if you're getting confused with should I have the n minus 1 or just the n, just think about it as the next term. All right, let's go down here now to C. This is the one that, a little worried about us there. Let's see what we got. We're finding the sum from the 0th term to the 5th term of this series. So let's think about this for a second. I'm going to write this in a little bit above it here, but right, we're going to have our 0th term, our 1st term, our 2nd term, our 3rd term, our 4th term, and then our 5th term. How many terms are there, right? There are 6 terms here, right? So n is really equal to 6 here. You've got 6 terms from the 0th term to the 5th term. So we need to find the sum from the 0th term to the 5th term. So the first term that we're going to deal with, right, it'll be the first term in the set that we're dealing with in the series, but it's the 0th term overall. If I plug in 0 here, I'm going to say 5 times 3 to the power of 0 minus 1. Well, 3 to the negative first power we know is going to be 1/3, not negative 3. So we get 5/3. So this is 5/3. Okay, now we take that, we multiply that by 3. This is like our 0th term. Our first term is, we multiply this by 3, that gives us 5. We multiply 5 times 3, we get 15. That's our second term. Our third term in the series here is going to be 15 times 3, which is 45. Then we've got fourth term would be 45 times 3, which would be 135. And then the fifth term in the series would be 135 times 3, which would be 405. So if we're trying to use the formula, though, we're going to say here, we're going to find the sum of the 6 terms here. And what we've got is we're going to use the first term in, so it's not this first term right here. It's not this first term. It's the first term in the set that we're finding the sum of, right? So it would be 5/3 times, our multiplier is 3 raised to the 6th power minus 5/3, all divided by our multiplier minus 1. Okay, so you could ignore all of these now at this point, right? When you did it there, because you're just looking at the set of numbers that you have. But I wanted to make sure that you were able to come up with this here, because this is actually the 0th term and not the first term as defined by what we've got over here in the problem. So you can use a calculator to calculate that part, right? If you want to go in there and do that there, I'm going to go ahead and just do it for time's sake. I know you're probably sick of listening to me, but you should end up with 606.6 repeating on that one there, or 606 2/3 should be the sum of that series. All right, hopefully you're feeling okay about this. And if you have questions, I expect that you're reaching out to me or to your teacher if you have a different teacher. Thanks for watching.